guys were absent. So again, we're going to separate, integrate, isolate, plug in your initial conditions. So whatever information they've given you, then we're going to solve for C, and then whatever we get for C, we're going to plug that back into the equation where we isolated Y. That's going to be our final answer. You guys had a quest due last night that had a bunch of practice on it. Some of you underestimated how long that would take you. There was one question on there that I think was especially challenging. It had U sub on both sides of the equation. One of the U sub, you had to like rearrange the U equals X minus 2 or whatever and move that around and then simplify. I made a video and I posted that on YouTube a long time ago, like 7 years ago or something, but that video is still relevant. Hopefully it helped if you got stuck. Always reach out if you have questions. You can reach out to me. I'll happily answer your questions or make an additional video if that's necessary. Okay, I want to go through an actual FRQ with you so you guys can see what it looks like. You can get an idea. Again, I'm recording this, so I'll throw this up on YouTube later. So you don't need to copy every single thing down. Let me read it to you. It says, consider the differential equation dy over dx equals negative xy squared over 2. Let f of x be the particular solution to this differential equation with the initial condition f of negative 1 is equal to 2. I want you to write down two things. This equation, dy over dx equals negative x y squared over 2, and your initial condition. F of negative 1 is equal to 2. This is important. Everybody should be writing down both of those things. Some of you look like you are doing other things, and it makes me nervous. Make sure you're focused. Okay, so that equation gives us dy over dx, and then we also have an initial condition. Common mistake I see is students are so amped up to do those 6 things, separate, integrate, isolate, all that stuff, that they just start solving that right now. This is a 3-part question. We're only on part A, and on part A it says, on the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. That has nothing to do with find the particular solution. This question is not asking you to find the particular solution. You should not be doing separate, integrate, isolate at all. That would be totally irrelevant to this question. What we're going to do is we're actually going to sketch what's called a slope field. So in your notebook, you might write the word slope field, so you know what this is. And then I would just draw a rough sketch of that picture provided. That picture will be provided to you in the textbook, in the test booklet, as it says in bold. And we're going to fill in the slopes for this slope field. So just draw an XY plane. It needs to go to negative 1 on the X, needs to go to positive 2 on the X, and then needs to go from 0 to positive 2 on the Y. There are 12 points indicated, so just draw a little dot at each of those points. Everyone should be doing this right now. Charlie, are you following along, love? Okay, just making sure. All right. Now, we haven't talked about slope fields, but they're not very challenging. Slope fields are generally worth 2 points. I should say any FRQ you take in calculus is going to be a total of 9 points. Okay, 9 points total. And so in general, a slope field is worth 2 points, getting the slope field correct. Okay, and it's not too challenging. It's mostly just some simple addition, subtraction, multiplication, division. And then drawing a little line. So I'm going to walk through how this works with you. For a slope field, what we're going to try to do is we're going to try to find the slope at individual places on this graph. So this graph is going to be the graph of y equals, but we don't care about the entire graph. What we care about is the slope at specific places. So our slope is represented by dy over dx. That's what the slope is. So if I wanted to, for example, know the slope at 0, 0, that's a coordinate. What I would do is I would write, please copy this down, dy over dx with that like vertical line. That means that's where we're evaluating it at. And then we're going to have the coordinate 0, 0 on the bottom. So go ahead and copy that down. That's saying that we're finding dy over dx, the slope, at specifically the point 0, 0. And to do that, we're going to plug in 0 for x and 0 for y into that slope equation. So that's going to give me negative 0 times 0 squared over 2, which is 0 over 2, which is just 0. So I get a 0 slope. What I'm going to put on the graph then is a small line segment with a slope of 0 at that point specifically. So I'm going to go to 0, 0, and I'm going to draw a small line segment that has a slope of 0. Looks just like this. Just a small line segment at 0, 0 with the slope of 0. Really important. You're not going to add dots to both these sides. You're not going to draw it like that. You're not going to put arrows on both those sides. That would be incorrect. You're not going to connect it to the dots nearby. That would be incorrect. Just a small line segment at that point. Make sure it's a big enough segment that you can see the slope. So some guys will draw like this. That's not a sufficient line segment. I can't tell what the slope is. That looks like a dot to me. So make sure it's like big enough, long enough that I can see the slope there. Okay. Any questions on that so far? So this might seem pretty tedious. Like we've got 12 slopes to find, right? And I don't want to sit here and have to calculate all of those. So something helpful about slope fields is there's usually a pattern with some of the slopes, meaning there's usually like a value where you're always going to get a slope of 0, or you're always going to get a slope of 1, or something like that. And so if you can identify that pattern, you don't need to show this work for every single slope. Okay, can anyone identify like a place where we would have a slope that you know off the bat? Samson.
I would say basically anything on the x-axis.
Anytime we're on the x-axis, sorry, go ahead. Anytime we're on the x-axis, what?
And the slope would just be 0.
The slope would be 0. Why is that true, Samson?
Because at the x-axis, y equals 0, so this could be negative some value of x times 0 squared divided by 2 to 0.
Perfect. Exact right explanation. So Samson's looking back at our equation and saying, well, anytime y is 0, that whole thing is going to be 0. And that happens along our x-axis. So along our x-axis, y is 0 that whole time. So all of those slopes, since they're going to have a y equal to 0, and I'm going to plug in y equals 0 into that equation, they're all going to give me a slope of 0. So without having to show all that extra work, I know that here at this dot, we're also going to have a slope of 0. At this dot, we have a slope of 0. And at this dot, we have a slope of 0. Does anyone else, someone besides Samson, see any other patterns that we would have for slopes?
Also on the y-axis?
Also on the y-axis. Jack's exactly right. So why is that true, Jack?
Because y is also 0, making it 0 over 2, which is 0.
Correct. So x is 0 on the y-axis.
Oh, yeah, that's
what you meant to say.
Yeah.
Yeah, so we would get also a 0 over 2. On the y-axis, x is 0 the whole time. Now, common mistake I see is guys will draw stuff like this. They're like, I don't know, it's just supposed to be on the lines. That's not a slope of 0. That's an infinite slope, right? So slope of 0 means a horizontal line. Make sure you actually have a slope of 0. It's very easy to do on the x-axis. But what I see is guys go too quick and then they draw something like this. That is not a slope of 0. You're kind of close to a slope of 0, but a slope of 0 actually needs to look like a horizontal line. Okay, so these are easy little things to do. Right now, you would probably have 1 point. So usually identifying the pattern and showing the slopes for any place where there's a pattern is the first point out of 2. So already we've got a point. Okay, this is probably one of the easier points that you can get on the entire exam. But we still have 1, 2, 3, 4, 5, 6 points left. So we've done half of them without a whole lot of work, but we've got 6 more points we have to sort through. So the next one we're going to do is this one at 1, 1. We'll figure this one out next. So we're going to go to 1, 1. We're going to do the same thing we did before. So we're going to have dy over dx at the point 1, 1. I'm going to plug in a 1 for my x. I'm going to plug in a 1 for my y. So I get negative 1 times 1 squared over 2, which is negative 1/2. So I have a slope of negative 1/2. First of all, you need to make sure your algebra skills are tight. I cannot see a positive slope there. So many guys miss points because they're like, oops, I forgot what negative slope looks like. Or they make it a slope of negative 2 instead of a slope of negative 1/2. So think back to like basics, right? Negative 1/2 means down 1, right 2, or it means up 1 and left 2. Please look up at the screen really quick. If we're right here, there's another point provided to us already that can accomplish either down 1 and right 2 or up 1 and left 2. And that point would be this point over here, right? If I started at this point and I went up 1 and left 2, that's a slope of negative 1/2. So what I'm going to do to make sure that my slope is correct is that I'm going to draw a little dashed line that connects those 2 dots. That is going to provide me with the correct slope because I went up 1 and left 2. That's a slope of negative 1/2, rise over run. but I don't actually want to use that whole dashed line. I'm just using another dot so that I get the correct slope. Once I have that slope, I'm going to draw my slope segment that I want right here. It's just going to be right on those dashed lines. And then I'm going to erase everything else that I don't need. And now I've got that perfect slope shown. Okay. If your slope is too steep and it looks like it wouldn't have passed through that point, you won't get credit, or too flat. If it looks like it wouldn't have passed through that point, you will not get credit. So it's the most important thing just to use the dots around in order to provide us with like an anchor for what our slope should look like. Okay, let's do this point over here. That point is -1, 1. It's important you know which one is X and which one is Y also, because if Y is negative, nothing, like it's squared right away. But if X is negative, it actually impacts the graph. So make sure you know which coordinate you're on and what's negative X or Y, right? So that point is the coordinate -X, so -1 for X, +1 for Y. So we get dy over dx at the point -1, 1. That means we're going to plug in -1, don't lose your negative, times 1 squared over 2. That gives me a +1/2. Right over there, we have a slope of +1/2. So we can do the same thing. That means we're going up 1, right 2, which means it would connect to this dot over here. So if I drew a little dashed line, made sure it went through those dots, try to get your line as straight as possible. You don't have a ruler for this exam, but that will help you get that perfect slope on there. So we get that slope of +1/2. I draw that and then I erase what I don't need. So I erase all of this extra stuff. Okay, and it should reasonably be mirrored, right? Like in that specific one, they won't always be mirrored, but in this one, we have it mirrored because I got a slope of -1/2, and then I got a slope of +1/2. Okay, questions on this so far on how this works or what to show? So a reminder on work, you don't have to show finding every single place. If there are easy, quote unquote, easy slopes or slopes that are obvious and have a pattern to them, then you don't need to show finding those. It is pretty helpful to find all of the other ones to make sure you don't make silly mistakes, but you might notice additional patterns. So let's do the one up here. Let's do the point 1, 2. Again, it's very important that you know what your X is and what your Y is. It's very easy to mess this stuff up. So we're finding dy dx at 1, 2. That's going to give me -1 times 2 squared over 2, which is -4 over 2 or -2. Okay, so now we have a slope of -2. That means down 2 and right 1, or left 2 and up 1, right? But I'm going to use down 2, right 1. That's going to put it through this spot right here. Again, I can draw a dashed line to make sure it would go through that spot. It's a reasonably straight line. I'm going to draw my little line segment, and I have a slope of -2 there. Again, be careful with your negatives. If you drew a +2 slope, you don't get any of that second point. So I said the first point is usually for like the 0 slopes or the easy slopes. The second point is all of the rest of them. So if one of your slopes is too steep or too flat, you don't get that second point at all, which should be a freebie point. Okay. Now on the left side, this point, the only difference between this point and this point is that X is negative. So we saw what that impacted already. That made the slope on the left the opposite to the slope on the right for this particular one. So we would end up getting a slope of +2 there. You don't have to show the work to find that if you can figure out that using this pattern. So we get a slope of +2. There's not really a dot that's going to help us here though, to get that slope of a +2, right? I don't have right 1, up 2, or up 2, right 1. And I don't really have down 2 and left 1. So you can either add another dot, right? Like this is 0, 1, -2. You can add another dot in a place that's reasonable, or try to match this slope and just mirror it so it's on the left side and negative, right? So we would approximately, if I took this one and mirrored it, I get approximately this. Okay. I think there was a question in the chat. Again, feel free to ask those questions out loud. Okay, Carlos, try to find a charger and good luck. Okay, any questions on this? I want to move on to other stuff. So slope fields, not too hard. Again, you're just finding the slope at each of those points. Do not draw arrows. That's a good way to get no credit on these problems. Do not draw little dots on here. Do not leave your dashed lines on here. So I shouldn't like still see a dashed line later. Make sure your line segments don't randomly connect to each other. They shouldn't be connected. Are there any questions? Please unmute if you have a question. I think I covered it all, but I want to make sure.
Ms. Foster, dy dx is just another way of saying rise over run, right?
Yep. It literally comes from, Charlie, it comes from delta y over delta x. That's the dy dx, which means change in y over change in x. Exactly right. Good question. All right, we're going to do part B. Again, don't get antsy and try to do your separable differential equation yet. It hasn't asked us to do that. Part B says write an equation for the line tangent to the graph of f at x equals 1. Write an equation of a tangent line we've been doing since like week 1 or week 2. That's basic stuff. We got to know how to do that. Write an equation of a tangent line means y minus y1 equals m times x minus x1. Anytime it asks you to write an equation of a tangent line, please start there. Hopefully no one is still writing y equals mx plus b. We were given the equation dy over dx is equal to negative xy squared over 2. That's what we were given. And we were also given a point, right? So anything that we're given is important to note. We were given the point f of negative 1 is equal to 2. Okay. Now we know some information off the bat because we know f of negative 1 is equal to 2. We know we're missing 3 things. We're missing x1, m, and y1. We can plug in our y1. So y minus 2 is equal to x minus negative 1, or the same as x plus 1. Now, please don't make this mistake. The last time I think I gave an assessment, so many students made this mistake, and you're likely to continue making it if you don't hear me now. It would be incorrect to write negative xy squared over 2 here. Can someone tell me why that would be incorrect?
Because you're starting at that specific point. You're starting at that specific point, and so like when you do negative xy squared divided by 2, that's like at any point when you're just trying to find the point of negative 1.
Exactly. So we need the slope specifically at negative 1. And exactly what Samson said, negative xy squared over 2 is like a general place. Like any place on the curve has that slope. We need the slope specifically at negative 1. So how do I go about finding the slope at negative 1? Specifically, I guess at x equals negative 1, y equals 2. How do I go about finding that slope? Hello, we just did this.
You look at your
Basically, do
points.
what you did on subfield,
Exactly. Do exactly what I
or
did.
just look at the subfield.
Okay, so we need to write that correctly. Dy over dx, this is not one that you are allowed to do in your head. Anytime you're presenting new numbers into an equation or something that you're using on FRQ, you have to show finding it. So I don't care if you can do it in your head. You will not get any points on this problem if you do not show all the work to find that dy dx. So that means labeling it correctly as well. So dy over dx at the point negative 1 comma 2 is equal to, we need to plug in, we have the equation negative 1, 2 squared over 2. That gives me positive 4 over 2, which is 2. You have to show that work. If you showed f prime of negative 1, you would not get credit. If you showed y prime of negative 1, you would not get credit. The only way to show the work and get credit is this. That's it. That's the only way you can do it. You have to do it this way. Okay. And now we're going to plug that 2 in here and we get this equation. Y minus 2 equals 2 times x plus 1. Sometimes they'll ask you an additional question on part B. And the additional question I sometimes see is use it to approximate. So they'll say like find an equation of a tangent line and use it to approximate, and they'll give us something like f of negative 1.1, for example. Okay, sometimes that's also a question you'll see here. And I think on the homework, there's a question like that. So I wanted to go through this. So we have the equation, let me just make some room. We have the equation y minus 2 equals 2 times x plus 1. We found that part in part B. write an equation for the line tangent to the graph of f at x equals -1. It wants us now to use that tangent line, so use that equation we just came up with in order to approximate f of -1.1. What that means is we're going to take this equation, y minus 2 equals 2, and in place of x, we're going to put in whatever they want us to approximate. So we're going to throw -1.1 into this equation. It's generally helpful to use fractions. It's fine if you don't. On this one, I think I picked one that's pretty easy. So we get y minus 2 equals 2 times -0.1 plus 0.1 is -1/10 or -0.1. Again, I don't care if you use a fraction or a decimal. Sometimes fractions are easier, but not always. Okay. At this point, we would get y is equal to, we have -2/10 plus 2, right? Which is the same as, again, if you were using decimals, -0.2 plus 2, or the same as 1.8. So we used that line to approximate another value. Now, the way that you need to write your final answer here is you need to write it given what they're asking. So they asked us to approximate f of -1.1. Your final answer would be f of -1.1 is approximately equal to 1.8. Okay, this wasn't on the original question. I just added this to make sure that you guys understood this process. This is all stuff we've done before. Slope fields, not really, but you understand the logic to get to those slope fields. Are there any questions on any parts of that?
Ms. Toster, I'm just curious. Do we have to put that in decimal form, or can we keep it in a fraction?
You can totally leave it as a fraction, 18/20.
Okay.
Or is 18/10, excuse me. Lol. 18/10 is fine. You also don't need to reduce, Chase, so you don't need to make that like 9/5. You can just leave it as 18/10 if you want. All good. Yeah, no requirement to reduce, no requirement to do decimals, whatever you're most comfortable with here. Often fractions will be easier. On this one, it was kind of either way. Okay, so we did part A, we did part B. Generally, part A and part B are worth 3 to 4 points. And then the last question, it won't always be part C, but the question that asks you to actually solve the differential equation will be worth 5 to 6 points. And a lot of times it's worth 6. Again, that's the most points you can get on any single question on the entire exam. This is one of the biggest topics. If you master this, you are already 6 points on the way to 40, and 40 is a 3, right? 6 points is a big chunk of that 3. So it's important to get that, okay? So the question, the way it's worded, says find the solution y equals f of x to the differential equation with the initial condition f of -1 equals 2. The other way they might word this is say find the particular solution. And you guys have seen that in a lot of the quests that you did. Okay, so find the solution or find the particular solution. I'm going to go ahead and start a new slide for this one. We get dy over dx is equal to -xy squared over 2. Don't work too far ahead on this one. I want to make sure we're all on the same page and taking the best approach possible. There's sometimes different ways to do this, but they make it harder on yourself. So the first step we need to do is we need to separate our x's and our y's. We need to get the y's on the left and the x's on the right. Common mistake I see is that guys will write y squared dy on the left side. Y squared is not going to be multiplied to the left side. Y squared is currently being multiplied on the right side. So to get it to the left, I need to divide it over. And so you could write dy over y squared. What I actually think is better is 1 over y squared dy, making it a fraction out in front. 1 over y squared dy on the left. Okay. Some students will also move the 2 over to the left side, like they'll multiply the 2 up. That doesn't really help us at all. So it's not really useful to move the 2 to the left side because eventually I want to isolate y. So I want to try to leave anything I can on the right side. So leave anything you can on the right side, only move y's over to the left side. Sometimes you have to move a number over to the left side because it's like in parentheses with a y or in a denominator with a y. But if you can, leave everything else on the right side. Okay, so I've moved that over. What I have left on the right side is -x over 2, and then I would multiply the dx up. But that's actually not going to even be the easiest way to write that. A divide by 2 sometimes gets confusing for guys. So anytime you can, take any constants and just move them out in front as multiplication. So instead of having negative x over 2, often it's helpful to write it as negative 1/2 x. Okay, right now we've got our first point. So we get 1 point just for separating. Again, I want to be really clear on this. If you wrote dy and then 1 over y squared, I've already stopped grading. You cannot get any points out of 6 because your dy is not at the end. Okay, your dy or your dx needs to be at the end, or if you accidentally multiplied or whatever, right? If you mess up this first step, we stop grading, nothing else matters. Next thing we're gonna do, so that was separate, we're gonna integrate. Be sure to draw your integral symbols here. Several of you, and I'm going through some of the feedback I've already provided, but several of you are showing the integral symbols at the wrong location. You should only be showing an integral symbol before you take an antiderivative. It's telling me I need to take the antiderivative. Once you've taken it, you should not be drawing an integral symbol anymore, okay? Tell that guy to get out of there with those newspapers. We're in class. Okay, so on the left side, we have 1 over y squared. Thank you, I appreciate everyone. So we have 1 over y squared on the left. Common mistake is for students to think that the antiderivative of 1 over y squared is ln of y squared, because they know 1 over y is ln of y, and so they mess that up. 1 over y squared is very helpful if you rewrite it as y to the negative 2. And you'll notice I just erased it. I didn't start a new line. I just erased it and included it there. So y to the negative 2 is really what 1 over y squared is equal to. You are able to take the antiderivative of that. So with y to the negative 1, we got stuck because we get y to the 0 over 0. The world explodes because we divided by 0. That's why there's an ln. That's not the case with y to the negative 2. For y to the negative 2, when I take the antiderivative, I get y to the negative 1 over negative 1. So not ln. There's no ln for this one, which is a common mistake. Okay, we've said before we're going to include the plus c on the right side only. So I'm not going to have a plus c on the left. That's all we're going to show on the left side. We have y to the negative 1 over negative 1. On the right side, I get negative 1/2. I'm going to leave that alone for now. Then I get x squared over 2 plus a c. If you forget your c, we stop grading. You need to have a plus c. It needs to be on the right side. Okay. Couple other common mistakes I see here. I'm just going to try to go through them as we talk through this. Students accidentally take a derivative instead of an integral. Don't do that. Make sure you're taking an integral. Also, some students will keep showing this integral symbol. I don't want to take the integral of anything else. The integral has been taken. Those symbols should disappear. They should not be there anymore. Do not include. Okay. All right, from here, we're going to rewrite this because our next thing that we want to do is we want to isolate y. So we want to try to isolate y. So we need to recognize what this equation really means. That y to the negative 1 sometimes is confusing. The left side, y to the negative 1, means really y is in the denominator. And so it's really like 1 over negative y, but that's the same as negative 1 over y. I would write it this way to make sure you understand that. We can also simplify the right side of this equation. I can move divide by 2 out in front. Samson, you're unmuted. Just a heads up.
Oh, sorry.
All good. So we get negative 1/4 x squared plus c. Again, it's generally helpful to combine constants and move them out in front as multiplication. Even if there's division, just make it 1 over. Okay. Now to isolate y, really what we're going to do, this is a place where students get confused. I would multiply both sides by y to bring y up, but then I would need to bring all of this stuff in parentheses back down. So I would divide that over. So what you're actually going to get, and you'll get better at just noticing this, you're going to get y equals negative 1 divided by negative 1/4 x squared plus c. So I multiplied the y up and I divided all that other stuff over so that y is now on top and I have negative 1 over everything that was on the right side. Okay. Now, common mistakes from here. Students think that they can split up the denominator. Like they think it's the same as having negative 1 over negative 1/4 x squared plus as like a separate fraction, negative 1 over c, which is not true. You can't break up a denominator like that. Like if I give you 2 over x plus 3, that is not the same as 2 over x plus 2 over 3. So I cannot break up a denominator. The c needs to stay in the denominator where it is right now. But before I start plugging in my initial conditions, this is why I didn't want you to go too far ahead. Before I plug in my initial conditions, it's generally helpful to simplify this fraction. Right now, there's a fraction within a fraction, right? I've got a 1/4 within a bigger fraction, and I've got a lot of negatives. I've got a negative in the numerator and a negative in the denominator. So I'm going to try to get rid of both of those things before I simplify, before I solve for c, before I use my initial conditions. And the way I'm going to do that, does anyone know? Does anyone have a guess about how I can get rid of the negatives and the fraction in the denominator? I'm going to multiply by something, top and bottom.
4.
Really close. So 4 will help us. What would help us even
Negative
more,
4.
Dominic?
-4.
Negative 4. So if I multiply my numerator, my big numerator and my big denominator by -4, it's actually going to simplify this equation quite a bit. It's going to make it easier to solve for other things going forward. So I'm going to multiply by -4 over -4. I'm going to get y equals a +4 up top, -1 times -4. In the denominator, I'm going to distribute this -4 to both of these terms. So when I distribute that -4 to -1/4, lots of stuff cancels. I just get a positive x squared. And when I distribute the -4 to the c, it's -4, a constant, times c, a constant. So it's really just another constant. So that's a much simpler equation, the one in green, to use. If this was multiple choice, they would likely simplify it this way anyways, and it's going to make it easier for us to solve for our c. However, if you plugged in your initial conditions in the yellow line or the black line, you cannot do this and you're going to get a wrong answer. You're going to have a different c. So that's why it's helpful to simplify your equation as much as possible before you plug in your initial conditions. Someone's still unmuted, just heads up. Is there a question? Okay, careful of your mute.
I have a question.
Yeah, go ahead.
Why would it not be -c?
Because minus c and plus c are both just constants, right? So you could do that, Charlie. You're just going to get the opposite value for your c. Your equation would be right in the end. I try to leave it as just plus c if I can. Okay, all right, now we've got to plug in our initial conditions. So again, we were given f of -1 is equal to 2. I think it's helpful to write that as x equals -1, y equals 2. It seems like a stupid thing to do. It's so worth it. It's so helpful just to take a moment and write it that way. Okay, now we're going to plug that in. So when we plug that into our equation, we get 2 is equal to 4 over -1 squared plus c. We're trying to solve for our c. We get 2 is equal to 4 over 1 plus c. Kind of like we did for y a second ago, we're going to multiply the denominator up and then divide the 2 over. So we get 1 plus c is equal to 4 over 2. 1 plus c is equal to 2. Subtract the 1, c equals 1. And now, last step, we plug it into this equation. We don't go back to the green equation and erase anything. We need to make sure all our work is in order. But now I'm just rewriting that equation, 4 over x squared plus 1, final answer. Any questions? Thanks for the applause. Okay, so from here, tonight, I think it's due Wednesday, but you have 2 FRQ homework assignments. So I think they each have about 3 parts. They're very similar to this. So I think there's a slope field, an equation of a tangent line, and a solve a separable differential on each of those. For FRQ, they should not take you more than 15 minutes, but they should take you about 15 minutes to get through the whole thing. Make sure you're showing your work every step because the work is what matters here. Okay, it's really, really important that your work is correct. I encourage you to work together. You're welcome to do that. Make sure that you get that done correctly. I think Canvas, you guys have like an extra class this week because you had a less one last week or something. Just check Canvas for the days we're actually meeting so that you don't show up when we're not here. Okay, and the FRQ stuff is due Wednesday. All right, we're going to move on to a new topic because I've got 10 minutes. So, you know, time to burn. We're going to talk about something called area under a curve. Some of this is review, and then we're going to add a little bit to this topic. So we're going to talk about area under a curve. Go ahead and write down area under a curve because this is a new topic we're talking about. And then draw those 2 quick sketches. They don't need to be perfect. Mine aren't. I drew f of x and I kind of made a little squiggle. And then I drew g of x and I made a little squiggle, but g of x is a little lower than f of x. It's kind of all that matters. Okay, so go ahead and draw some squiggles, little XY plane, some A's and B's. Who is unmuted, y'all? Get it together. Chase is pointing at someone, but I can't
It's
see
the
who
quiet
he's
room. It's that
pointing
table
at.
over there. It's that table over there.
Okay, so this part should be a review. If I asked you to find this area, so the area under f of x from A to B, and when I mean the area under the curve, I specifically mean the area between the curve and the x-axis. If I asked you to find that area under that curve, we would be taking an integral, and we would be taking an integral from the bounds from x equals a to x equals b of f of x dx. We know that that's what that finds. Like when I have a bounded integral, hopefully you remember that that means we're finding area. We're finding the actual area under a curve. So that would be the area from A to B, right? And similarly, please focus, even if this seems easy, I want to make sure we don't mess this up. Okay, if I was to try to find the area under g of x, I would find the area from A to B of g of x dx. And that would give me the area that's between that curve and the x-axis. And it doesn't matter if it's above the x-axis or below the x-axis, it finds the area between that curve and the x-axis every single time. Okay, any questions on this part so far? Everybody's good on this, thumbs up. Area under a curve. Okay, so now what we're going to talk about is area between curves. This is a new topic. So again, we have our f of x and our g of x just on a separate line underneath. Go ahead and draw these again. So I've got my f of x squiggle a little bit higher, my g of x squiggle a little bit lower. What we just said was that the area under f of x, so all the way to the x-axis between a and b, so this area here, this whole area can be found by doing the integral from a to b of f of x dx. That's going to get me that whole area under f of x. If I just wanted the area under g of x, so that would be this area here, I would take the integral. Let me show the area. So if I just wanted that, I would take the integral still from a to b, but this time of g of x dx. Now, what you're often going to be asked to do is to find the area between two curves, meaning the area I now want is actually this difference of area. So I want this area, the area between these two curves. Unmute if you think you know how we would find that area between those two curves.
Subtract the f of x, or subtract the g of x minus the f of x. Like
So you want to
the
do
integrals.
g of x minus f of x?
Oh, no. Okay, so it'd be basically the first term in blue that you have minus the green term.
Fantastic job, Kevin. So what we're doing is if that whole area, right, is the area under f of x, and then we have that second area, the one in green under g of x, and I want the area between, I want the difference, Kevin's exactly right, we're going to subtract. And since they have the same bounds, I can actually write this as one integral, which you're almost always going to be expected to do. So I can make one integral, that would be the area from a to b, or I'm sorry, the integral from a to b of f of x minus g of x, all with respect to x. If you forget your dx, I've stopped grading, no credit. Make sure you don't forget your dx. Okay, that would be the area between those two curves. Hopefully that logically makes sense. Okay, now an important thing to remember, I've got some bones written out here. We are always going to do, if I have from x equals some a value to x equals some b value, whenever I'm trying to find the area between curves, anytime, I'm always going to do the top curve minus the bottom curve. Always. Top curve minus bottom curve. As long as we're with respect to x. We are going to talk about it with respect to y, meaning we're going to have y bounds and we're going to have an equation in terms of y. So it's instead of going to be a function like this, it might be a sideways function. then things are going to get a little different. But with respect to X, we're always going to do top minus bottom, always. Okay. And our value is always going to end up being a positive value, always. So we're always going to do top minus bottom for area between curves, and our value will always be positive. I want to give some additional examples. So some guys get confused. We did one where everything was above the x-axis. What happens if it's below the x-axis? So let's say I have my f of x squiggle here. I'll call it f of x. And I've got my g of x squiggle here. And then we've got our a and our b. Okay, I'm going to just make up some numbers here for actual values of integrals. Let's say my integral here, so that's a negative value, right? My integral from a to b of f of x dx, since it's below the x-axis, we know we would get a negative number. Let's say it's -3. Then if I found the area from a to b of g of x, that's also negative. It looks like it's even bigger, right? There's more area under the curve or under the x-axis. So it's even bigger negative number. Let's say it's -10. So some guys think they want to do like the farthest away from the x-axis. You don't. You still want to do top minus bottom. So I'm still going to go from a to b of top. The top function is f of x here minus the bottom function, which is g of x. What would happen, the integral, since the integral of f of x is -3, I would get -3 as the first outcome minus a -10, or the same as -3 plus 10, which will give me a +7. Area between curves must be greater than 0, must be a positive value. Okay. What we found was 7 was this portion here, that the area between those curves was a value of +7. Okay. Let's do another example. Sometimes one curve is above the x-axis, like this. Sometimes the other curve is below the x-axis, like this. We'll still give ourselves an a and a b. And now our area above the curve, well, that's going to be a positive value. So let's say it's, I don't know, 4. And that 4 is representing that area of, so the integral from a to b of f of x dx, I'm saying is equal to 4. Let's say our area integral from a to b of g of x is, I don't know, some negative number, -2, something. We are still going to do top minus bottom if I want the area between the curves, which means we're going to go from a to b of top f of x minus bottom g of x. In this case, that would give me a 4 minus a -2, which is a +6, which should make sense because down here I had -2, up there I had +4. My total area between those two curves is bigger than either of those values because now I'm finding all of this area here. Okay, does that make sense? Questions on that? Okay, we only have 2 minutes. I want to start a very quick example and just set this up. We're probably not going to have time to solve it. This question says, find the area bounded by y = x and y = x squared. It doesn't tell us our a and our b, so we have to be comfortable graphing this. If I draw y = x, that's a line. Please draw this. Y = x is a line. Looks like this. And then I would also have y = x squared, which is a parabola. So I get a graph that looks like this. It wants the area bounded by those two graphs. So there's this area here where we're bounded by these 2 points. We can find those 2 points by setting the equations equal to each other, right? That's how we did that in Algebra 1 and Algebra 2. We found them by setting it equal to each other. We don't just cross out x, we subtract. So we get 0 = x squared minus x, or x times x minus 1, or x = 0 and x = 1. That should make sense. That's the place where both of those intersect. So by setting up our system of equations, we found our a and our b. we would say that the area is equal to, well, we know our bounds. Our bounds are going to go from 0 to 1 because that's where they intersect. Okay, so that's how we're bounded. Now what I need to set up is top minus bottom. So our top equation here would be which equation? Oh, I guess we're about out of time. Our top equation would be the linear function. So we would have x minus, and then our bottom function would be x squared. And again, don't forget your dx. From here, all you're doing is taking the antiderivative, x squared over 2 minus x cubed over 3. You'll notice I don't have an integral drawn because I already drew the integral. I already took it. I do need a vertical line with 0 and 1 on there. So make sure you have that vertical line when you're applying your bounds. We get 1/2 minus 1/3 minus 0, or the same as times 3 over 3. We get 3 over 6 minus 2 over 6 equals 1/6, a positive value. That would be the area under that curve. Okay, we're out of time. I'm gonna let you guys go. I'll stay on if anybody has any questions. Otherwise, have a wonderful day. Make sure you get going on your FRQ for differential equations. Reach out if you have questions.
Thank you.
Thanks, guys.